Welcome. In this short video, I want to reflect with you on a simple question. Why does relativity and deep physics more generally still matter today? Relativity is more than 100 years old. It can feel far from daily life or from exam syllabus. I will offer two kinds of answers here. Some very concrete, practical reasons that you already might be familiar with, and a deeper, more human reason that is beyond, you can say, the technology and jobs and so forth and so on. Many students and many adults ask us something like this. Relativity is more than 100 years old. What is the use of such old things today? It is a fair question in a way. Not everyone will become theoretical physicists. Not everyone will ever write down Einstein's and similar equations at their work. So in this video, I want to give you two types of answer here, as I mentioned. First, few practical reasons where relativity really shows up in modern technology and science. And second, more important and human answer about what happens to us internally when we engage with such kind of thinking. Now, both levels matter. Let us begin with something you probably use almost every day. You know, GPS, your smartphone, your car's navigation, and mapping, Google Maps, even logistics rely on GPS. Now, GPS works because satellites they orbit around the Earth. They are precise and they have this so-called atomic clocks. Now, and our devices receives signal from many of the satellites, maybe three satellites. And by comparing these signal timings, it is positioning system uh, gives the position. Now here is where relativity enters very quietly. These clocks are moving, these clocks inside the satellites moving very fast relative to Earth. According to the special relativity, moving clocks tick slightly more slowly. We all know this. Mm. At the same time, satellites are higher, less gravitational field. No, maybe three. So, according to general relativity, clocks in higher gravitational field tick slightly faster than the clock in the deeper field. That also many of you might be. So, if not, it's okay. Both effects are small but not negligible. You will see why. Because over a day, the difference accumulates. See the small part. Now, these engineers must calculate and correct this small time shifts. If they ignored this relativity, the GPS position would be kilometers far each day. You see? So every time you watch that little, you know, dot on your phone or whatever device which says wherever you are, arrow, you are quietly using relativity there. You realize that? Okay. This relativity also sits at the heart of modern physics and many important relevant and consequent technologies. One of them is particle accelerators. They are very large labs and they accelerate uh, these electrons and photons to very high speed. Now at the such speeds, mm, you have to account for relativity, very obvious, because effective inertia changes and the collisions live longer than they would at the rest. Then that is now this longer living is the consequence of time dilation. Sorry. Our understanding of most fundamental particles and forces so far is built on the relativistic theory. Astrophysics and cosmology that we talk about, for example, neutron stars and bending of light around the massive bodies, expansion history of the universe. This is direct general relativity and special. They cannot be possible without this. And the nuclear power, uh, we we can harness it comparatively low cost. There are certain other issues with it, but it has E equal to mc square, which is central. And this fusion, which is how scientists try to see how sun shines. They want to even penetrate into the core of life-giving sun. Okay, so these are the practical things that I was talking about are very much alive in modern science and technology. Now let us move different kind of answer. Even if you don't work with GPS, engineering, particle physics, astrophysics, relativity still matters. Another and very important reason, which I believe, it represents special kind of thinking. When you study relativity seriously, you are doing several things. For example, you are questioning ideas we usually take for granted. For example, space, time, simultaneity, motion. You are insisting that our description of nature in which we live and we are integral part of nature be logically consistent for all observers, yeah, not just for one chosen frame. Therefore, you are willing to modify deep intuitions about reality eh, and in a way about yourself when the evidence and the reasoning demand for it. So, engaging with such idea trains our mind. It teaches us look beyond the habit and prejudice, stay with temporary confusion while you search for a clear picture, and respect both reasoning and experiment, even when they go against our first intuition. This training does not end with physics. It spills over into how you approach the complex, demanding, ever demanding questions in life. Today, education is often discussed in a very narrow terms. Example, will this help me get a job? Will this be asked in exam? Important questions, so forth and so on. Those are concerns which are understandable, but they are not the whole story. Some parts of the knowledge have a different role. They are soul elevating, so to say. They do something for inner life. When we ponder relativity, we are not only manipulating equations. No, we are asking what time really means. You see, asking how two honest observers can disagree about whether events are simultaneous and both still be right. Discovering that nature is more subtle, more beautiful than uh, everyday experience suggests. There is a quiet joy in watching your picture of the world uh, deepen as you understand these ideas. See, it's a kind of inner expansion, joy. So, why does deep physics like relativity still matter today? You may never have to compute a Lorentz force or Lorentz factor at your desk. You may never open a research paper in general relativity. But learning such theories can sharpen your capacity to think clearly about complex systems, strengthen your respect for careful reasoning and honest experimentation. Sorry, and give you the sense that you are connected to universe at a profound level, that your mind can reach out and understand something as subtle as space and time. And if universe willing, we may go beyond space and time. In that sense, now the use of relativity is not only in the machines we build, you see, or GPS or large uh, collider or whatever that we enjoy today. It is also the kind of mind we slowly build within ourselves. So I would like to end with a simple thought. Sometimes Neil Morse also sounded similar to this. Physics, like relativity, is not only about what we can do with it, it is also about what it invites us to become as thinkers. If you allow it, exploring such ideas can be both intellectually satisfying and quietly nourishing for the inner life. Thank you for listening.